So my friends, I'm taking a look at page 153, 154. What kind of questions do you have for me on 153, 154? What could I help you with? No questions? None? Zero zip? How much? 4?
For the first three,
Uh-huh.
do you plug both x and y?
Oh, okay. Kind of. So like if you took a look at problem number 1, they give us this y hat equals 4.15 plus 0.65x. So remember, guys, in stats, the hat means that we got the equation from data. That's what the hat means. And they list it. It's not in slope-intercept form because they have it out of order. They have it as y equals b plus mx versus y equals mx plus b. But then they give us this point. Okay, it says, so things that we have to realize. We have the point -2 comma 4 here, and then we have like 4.15, and it's got a mild slope. So we have kind of this line of best fit. I don't know if that dot is technically below it or not. It might be. We'll find out in a moment. But that's what we're taking place. So this is our line of best fit. This is what we use predictions on. This is the actual data. Okay? Actual data point. Okay, obviously there was probably a lot more of these that were used in order to get that line of best fit, but that takes place. So what we're going to do is I'm going to take my x value and I'm going to plug it in for the x here. So I'm going to go y equals 4.15 plus 0.65 times -2. And what'd you get roughly? And is it about 2.85? Oh, it is It is 2.85. That's what I'm showing. Make sure you done all that. If you're doing it on your calculator on your phone, multiply this first and then go 4.15 combined with that. Okay. So what's going to take place is now this is a y value. This is also the y value. So we are predicting that we get a 2.85 in this situation, but our data showed us this. So our point should be above this because this is the point -2 comma 2.85, where this is the point -2 comma 4. So the point itself has some data there. There is a residual value there. That red up there is the residual value. So you want to then subtract the data minus this. So I'm going to go 4 minus 2.85, and that's going to give me, I have a residual of 1.15. The 1.15 means that I was above our predicted. If it was a negative value, it means that dot would go below it. Okay? And that's the same thing you do for 1, 2, and 3. 4, you're creating your line of best fit and doing the same exact stuff for it. So positive, if your residual is positive, that means your data point lies above your line of best fit. If it's negative, that means your data point lies below. So your predicting part is our prediction. Our prediction is lower than the data point showed. Okay. All the rest of the problems are basically doing the exact same information. Okay. Number 11, it just on the second page, I think that's the same. It appears that, we have this correlation, your R value. Now remember, your R value is different than your residual value. Okay, the residual is the distance your data point is from the predicted line of best fit. Your R value is kind of the summation of all of your residual values. And a 0.0872 is really, really cruddy. That's like getting an 8% on a test. None of us want an 8% on a test. Cool? All right. Friends, do you feel okay about this page? The predictions are valid. Let's see, we're going to go to 2.8. So where am I at? Too far. 2.8, 2.8, 3.1. I think we are slated to do a quiz on Monday. We will review on Friday. I will put all of the answers up for the review as a video on Schoology so you could watch it over the weekend if you chose to study. All right, my friends, I am on page 49 of our notes. And where's my coffee? Because I want coffee. I mean Jack Daniels. I mean coffee. I have lots. How about that one? You can keep it, bring it to me the day you graduate.
Okay.
At graduation, we all have our robes on. Bring it. Cool. I keep saying that, it's yet to happen. All right, page 49. This is section 2-8, residual plots. Residuals need to be studied closely. And there's a new data display we can create to study them simultaneously. It is called the residual plot. We've already talked about this. Now, the difference between if you had plotted data and you created a line of best fit based on that data, the residual values are these vertical distances. Okay? If I plotted my residual plot as well, that's going to be like this. So take a look at the black dots are the residual results. They are hovering above and below the x-axis. Okay? So it's kind of hard to, think what's really taking place here other than those data points happen to fall above or below my line of best fit. So what's taking place is this distance right here is related to this point right here. Okay? So how far above the x-axis is this point? Okay? And it refers to any of them. That distance happens to be the same distance, but above line of best fit. Line of best fit. Okay? So that's what the residual plot does. So if I show you a residual graph and saying, hey, what can you conclude off this? If you have things that are right above and below, you're like, you know that your line of best fit isn't perfect. If your line of best fit was perfect and all your data fell right on your line of best fit, your residual plot would be right on the x-axis. It's not a distance above or below it. Okay? So on page 49 it says the diagram below shows both a scatter plot and its associated residual. Okay? So if you look at the data plot that they have drawn, you have your scatter plot, line of best fit, and then they have the residual plot where basically they have a line right here calling this 0. That's basically the x-axis. And they're just having data points above and below. Okay, those are the distances that my data points are for my line of best fit. My line of best fit is the line that I use, or the equation I use, in order to predict values for, what would happen. So the left is a scatter plot. It shows the explanatory variable, the response variable, and the linear regression line. The residual plot, the left one, or this one, the residual plot, it's replacing the response variable with the residual value for that point. Take a quick look at the two leftmost, and they say orange points. So if I had, let's say I had this value here. Let's say I had this data point here. So this has a huge residual. Okay, that distance is huge. That means if this was the x-axis, this point would mimic being way the heck down here. So this distance here and this distance here are going to be the same. It's just a different way of looking at it. Okay? Let's see. The residual plot, both points, leftmost points have a residual. They're talking about that, so they're based on that. So why do we need a residual plot when we can see the amount of error each point possesses in the original scatter plot? Okay, so the question is, why would we want to even look at both of these pieces of data? They give you two different pieces of information, line of best fit, data points, versus how far my data points are from vertically from my line of best fit. Okay, so the residual plot creates a visual display in which the errors, the distance each point is from the regression line, is what I just said, so are exaggerated. The residual plot often makes patterns emerge more clearly. Question number 2, what do we look for in a residual plot? If we see patterns, when you detect a specific pattern in a residual plot, it usually means your prediction model has room for improvement. So again, we're talking about if you're doing statistics. We have been part of a statistics soup our entire lives, okay? There has been all kinds of things. What should we do with this way? Should we do? You all are subjected somewhere earlier in your lives learning the concept of quote-unquote Common Core math. Do you remember ever hearing that? And there's all kinds of jokes about Common Core math. Okay, and they're like, oh, well, they use it in this country, and this country does great. Okay, then they used to do ads on TV, usually around election time, saying how poorly the United States does compared to other industrialized nations. And so the publishers of textbooks jumped on that bandwagon saying, yeah, look how bad we're doing. Look how bad we're doing. Okay? Now, I want to tell you this. Okay? I know a lot of people will sit there and they will point fingers at public education saying it's not doing its job. Okay. So the countries that they were comparing the United States to based on some sort of test, I don't know what test it was. I asked about the test one time at a meeting, and they said, well, there was a test. I said, I've never missed school. When was the test given? Oh, there was a test given. Can you tell me what the test was? Well, there was a test given. What test was it? It was a test when you weren't there. I've been there every day. Well, there was another day that you weren't there that we gave it. No, I've been there every day. Kid you not, this is the argument. I'm arguing with the sales rep of Prentice Hall, a major textbook publishing company, who is just lying to me about a test because this guy wants me to go back to my school saying, dude, we need these textbooks because of sales pitch. Okay, now they would run ads on TV. Prentice Hall was running ads on TV. Now, you didn't know it was Prentice Hall, but it was. And they'd sit there and say, look how bad America is doing in comparison to these other countries on a test that they can't tell me when the hell it was given. Okay, now I'm just one guy. So I'm only giving you one data point perspective. But I'm going to tell you what, I'm an asshole at those things. I challenge the living heck out of those people. Okay, I get it. Everyone should be able to have a career. Everyone should be able to make money, live a good life. I get it. But when you're habitually lying to me and your consumer, I don't want to deal with you. So let's go over, let's just say America did have this test that we all took at some point. And we did compare, and we did worse than these other 18 countries. Who do we educate in America? Like Yes, I know we have kids who ditch, and they miss all the time. And they'll tell you, oh, you don't need school. But yet they're sitting at home playing video games nonstop, and we don't need school. Well, the well's going to run dry for those people at some point. Okay? We try in the United States, if you have a child and your child becomes of school age, that child is entitled to go to school. Those other 18 countries that do better than us, when you are 5 years old, they will test that kid. That kid seems to be good in school, they're going to put them in school. If they're not, they're going to have them go work in a factory. Okay? And then at about 4th grade, they're going to retest the kids that they tested already. So now you have these kids that are tested. They're going to retest those kids already. Hey, you know what? Your kid is doing pretty well. Therefore, we're going to push your kid this direction. We're not going to push your kid. Your kid didn't do so well in 4th grade. We're going to push them in this different direction. Then in 8th grade, they're going to do the same thing. And then in 10th grade, they're going to do the same thing. So by the time they get to this fictitious test that supposedly we all took, you are taking 100% of the U.S. population kid and taking a test compared to about 5 or 6% of the population of a country that separated kids throughout education. So they're taking the top of their top. So what should we really have probably have done? Okay, you want to compare your top 5%? Okay, we'll bring our top 5% and let's compare. They didn't do it because it makes America look, bad. Education's bad. Education's not doing their all you're doing with education is indoctrinating kids. I'm teaching you guys math. I'm teaching you logical, progressive thinking. Okay, what do you learn in other classes? I don't know. I'm not in there, but, hey, I know that there were certain things I did in high school that I was like, dude, Romeo and Juliet, I will tell you right now, has done nothing for me in life other than something for me to make fun of. Okay? Now, I apologize if you love the story. I know some people do. I get it. But they didn't work for this guy. You know, it's the only book I read in high school that I actually enjoyed? Lord of the Flies. Okay? About a plane crash, a bunch of little kids that get on an island and they start killing each other. I thought that book was great. I loved it. Okay? Why? Because I'm a morbid person. There's some book we had to read as a freshman with Pip and Orlick, and I'm like looking at this going, dude, is there somewhere someone's getting shot? No, but this person doesn't like this other person. Oh, no. This can't happen. My sarcasm, don't let my sarcasm inspire you in any bad way. Okay, I'm on page 50. It says, consider the following residual plot from the University of Toronto study. Okay, if you look at the plot on page 50, it basically has peaks and valleys. Okay, there are distinct patterns to this residual plot. It says before 1996, the response variable is always lower than the regression predicted. Between 2000 and 2002, and I'm just looking at the graph, the response variable is always higher than the predicted. And after 2003, the response variable is always lower. If we have a good feel for the way our regression model is making our errors, shouldn't there be a way to fix those errors? The quick answer is yes. That would be when your regression model is showing a distinct pattern. Okay, so our thing, so we have our line of best fit, we have our x-axis. Friends, if we start seeing like a pattern that's doing this, there's something that took place. There's something that took place prior this way, there's something that took place prior this way, and something happened in the middle. Okay, yeah, it kind of looks like a parabola. I kind of made it exaggerated that way for a reason. Okay. So the quick answer is yes, when our regression model is showing distinct patterns to the way of making our errors, we should search for a new model. Okay? Meaning, if you look at the residual plot and you see a pattern that you could definitely see, you're not looking at good stuff. You're not looking at good data. Go research something else. Go from TikTok to Snapchat. Okay? Because I know that's where you guys get a lot of your information, which unfortunately should be just vital for entertainment. Okay. Down below on page 50, in the study, whether pneumonia, the following residual, they're in a study of whether pneumonia, the following residual plot was produced. Okay? If you look at the plot at the bottom of page 50, there's not a distinct pattern. You have probably the same amount of points above as you do below the x-axis. So those distances, those residual distances are probably going to be pretty close to being the same. Okay? Page 51 says, caution, residual plots tell you nothing about the strength of the relationship between explanatory and response variables. The only way you could tell whether your model fits the shape of the data well and whether you should search for a better model. So consider the following. You have a fitted line that's pretty close, and your residual kind of has some above and below. It says the correlation R, and this is on page 51 middle, is about 0.966. Okay, 96.6%. Okay, that sounds pretty good. This is deduced from the value of R squared. This is indicated for a very strong relationship between variables. You can see from the scatter plot, the points do in fact fit closely together. However, the residual plot on the right showing the distinct pattern, in this case, our model shows a powerful tendency to underpredict the response variable values of the explanatory variable lower than 30 and higher than 50, between 30 and 50. So if you look between 30 and 50, there's something that's taking place, something definitely below our line. Okay? Our model has a powerful tendency of over-predicting the response variable. So there's a strong relationship between the variables according to our regression model, but we should still look for a better model. Okay? So the residual graph pattern is shown, or something's happened to the left or to the right or in the middle, that's obvious. You need to look for different research. Okay? Now, COVID. Yes? It's all around us. We've all been exposed to it. If we haven't, we've been so isolated from people, but we've been exposed to it. Doesn't mean we caught it, but our immune system works. Some of us have a stronger immune system than others. Okay, some of us might have had a weakened immune system because you might have been sick prior, so your immune system's ramping back up. So it's easier to get sick after you've been sick. Not with the same thing, just different things. So let's say you looked at the data for COVID and you saw a pattern on your residual. You need to question it then. Say, hey, you know what? I want to research something different that's related to the same topic. Okay, cdc.gov, you want to know anything about any drugs? cdc.gov is incredible amount of information, incredible amount of studies that are accepted. Okay, and you're like, oh, but it's .gov, man, I don't know if I should trust it. Dude, I would trust the .gov a heck of a lot more than Snapchat and TikTok. Okay, or your friend forwarded you a Facebook post. Okay. All right, page 52, almost done. It says, notice the errors are relatively small for the x values below 65 and increase rapidly for the x values higher than 65. Often the residuals form a fan shape or maybe cone shape that qualifies as a distinct pattern. In the case, though, the pattern does not necessarily indicate that the regression model was a poor fit for data. Rather, it indicates that the model is making a much better predictions for some x and poor predictions for other x values. This isn't the issue to fit. It's because no curved regression model can fit this issue. Sometimes something else is going on, something more subtle, but maybe be more worth investigating further. Okay, I'm done with that. I have an assignment for you of some sort. I forget what page it was. We're on like 2.8 or something like that. Is that about right? 2.7, 2.8. All right. So page 155, 156 is what I'd like you to work on for next time.